Hello. In this video, we're going to look at a few different reactions that are either going to fall into the elimination or substitution family. These reactions are to just build on some of the practice problems that we went over in class. We'll start with this reaction here, the second one on the screen. I don't think we got to this one in class. Let's look at the reagents first. We have potassium hydroxide. So this is going to be classified as a strong base and a strong nucleophile. We have a polar aprotic solvent, which will lead to SN2E2, and we have a secondary alkyl halide. So the combination of all three of these factors will point us in the direction of SN2E2 and with a higher weight on SN2. So the product here will be the SN2 product, and we would also see a small amount of the elimination product potentially form due to the presence of a strong base. Alright, next we have sodium cyanide as a reagent for this, and then we have a mixture of two solvents. We have both ethanol and water. Now ethanol and water can act as nucleophiles, but in this case we have sodium cyanide, which is a strong nucleophile, and we have two polar protic solvents. So while the solvents might point us in the direction of SN1E1, first of all, we don't have a base at all. We don't have a strong base, so we can pretty much rule out elimination from occurring here. But we have a strong nucleophile and we have a primary substrate. So since the substrate's primary, that's going to point us to SN2E2. And since we don't have a base and we have a strong nucleophile, that'll be primarily SN2. So we'll have a SN2 reaction where the cyanide replaces the bromine. Remember, cyanide is a way to increase the bond length by the carbon chain length by 1. Alright, in this next problem, we have a tertiary substrate. So that will point us in the direction of either E1 or SN1 or E2, depending on the nucleophile and the electrophile. Sorry, the nucleophile, and if it's a base or not. And then we have a methanol water combo. Now these are polar protic solvents, so this will point us to a SN1 or E1, and we don't have a strong base. Now both of these can act as nucleophiles because we have a combination of the two. So we'll start in the mechanism by forming the carbocation at this position, and then either methanol or water can attack the carbocation. So we'll obtain both products, and I just have two products listed here, but remember, since the mechanism is SN1, we will also have the enantiomer of both of these products form in this reaction. This next problem we did in class, this is an SN2 reaction. The biggest thing to be concerned with for this problem is we have only one equivalent of the nucleophile, so it could either attack the secondary or the primary leaving group, and since it's just one equivalent, we can only attack one. It's going to attack the less sterically hindered leaving group. And for our final reaction, we have ethanol. So this is a polar protic solvent. It's also a weak nucleophile and weak base, and we have a tertiary leaving group. So these factors will point us in the direction of SN1. We don't have a strong base for elimination. We have a tertiary substrate, so it's not going to do SN2, and so we'll obtain the SN1 product, nucleophilic attack at this center, and also not shown here, the enantiomer would form as well.